Hi, this is Halal. In this video on mathematical economics series, we will solve a numerical on the input-output model. We are given the two industries and we have to find the gross output for each industry for the final demands 18 and 44 units respectively. We are given two industries, industry 1 and industry 2. Here the columns shows the purchase of inputs by the industry 1st and industry 2nd. Similarly, the row shows the sale of outputs. So across the row we have the sale of output or output produced, and across columns we have the purchase of inputs. Our final demand is given as 4 and 32. Therefore total output is here, and that is 16 plus 20 plus 4, that is 40, and similarly 8 plus 40 plus 32, which is 80. We have to find the gross output or new output if this final demand changes from 4 to 18 and this 32 to 44. If this column changes, what will be the optimal or what will be the output to be produced? So we will see how to solve this question. In the earlier video we have seen how to form the technical coefficient matrix. So first of all, we will form the input output coefficient. So solution will be we will form input output coefficient matrix. For this what will we do? This is formed by, as we have seen, we will write here A is equal to, we have to form the input output coefficient. Now first item here will be that is here, to produce 40 units of output we require 16 units from industry first. Therefore to produce one output we require 16 divided by 40. So we divide 16 this by 40. We have seen in the earlier video how it is done. So first will be 16 divided by 40. Similarly here this is also 8 divided by 40. 8 divided by 40. Also here this 80 units are produced by 20 units of this industry. Therefore to produce 1 unit of output, therefore share of this industry will be then 20 divided by 80, and similarly here it will be 40 divided by 80. In the earlier video I have shown you the whole idea how it is constructed. So I have done some calculations, so I will write here to be sure that this comes out to be precise one. So when solving this, this will come out to be 0.4, this is 0.2, this is 0.25, and this is 0.5. So this is our input output coefficient matrix. Now we have to use the formula which we have calculated in earlier video, that is gross output will be equal to, that is x is equal to I minus A inverse times the new demand. So I will write here D. Now first of all we have to check the condition that is called the Hawking-Simon condition. The Hawking-Simon condition says that the determinant of this input output coefficient matrix should be greater than 0. That is, this I minus A, this is called Leontief matrix. Now it is determinant should be greater than 0. First of all we have to form I minus A matrix. Now I is the identity matrix, so we will write in place of I will write 0, sorry, it is 1 0 0 1 minus A. Our A is this very input output coefficient, that is 0.4, 0.25, 0.2 and 0.5. Now when solving this will come out to be, now 1 minus 0.4, this comes out to be 0.6. Similarly 0 minus, this will become 0 minus 0.25. Similarly 0 minus 0.2, that is minus 0.2, and 1 minus 0.5, that is 0.5. So this is our, therefore our I minus A. This is our I minus A matrix, which is 0.6 minus 0.25 minus 0.2 and 0.5. First of all, we have to check the input, the Hawking-Simon condition. The first condition is that the determinant of this very matrix should be greater than 0. So taking determinant of this matrix, so this is I minus A. We have seen in the earlier videos how to take the determinant. We multiply these two elements. So this is 0.6 times 0.2, and from that we subtract the product of these very elements, that is minus 0.2 times minus 0.25. Now I have done the calculation. This comes out to be 0.25, which is greater than 0. So the system is feasible because the determinant of Leontief matrix is greater than 0, so we can proceed further. Okay, now we have to find I minus A inverse. How it is found? We know that I minus A inverse is equal to 1 divided by the determinant of I minus A and multiply it by adjoint of I minus A. Now our determinant is this 0.25, so I will write 0.25. Now adjoint of this matrix, it is very simple to calculate here. If we are given the 2 cross 2 matrix, the adjoint is formed by, so I will write here adjoint will be, so I will write here the matrix I minus A. First of all, we interchange the principal diagonal elements, that is we interchange 0.6 with 0.5. so first of all, this will become 0.5 here, and this 0.6 will come here, 0.6. To find the adjoint, we interchange the principal elements, and the non-principal elements, we write them same but change their sign. So we write here 0.25, here 0.2, but we change the sign because here it was minus. I have changed it to plus, and it is here minus, and I have changed it to the plus. So it's very simple. If we are given a 2 cross 2 matrix, this like the adjoint of this is, we change the elements, principal elements, or we interchange rather them, and non-principal elements will remain same, but their signs will be changed. If they were minus, we will be form them plus, and vice versa. Now, so this is our adjoint. So this is the adjoint of I minus A matrix. Now the calculation will get somewhat tedious. I have actually solved it. So this comes out to be, so I will write here, this very comes out to be 0, this comes out to be 2, 0.8, because we have to divide every element by 0.25. so 0.5 divided by 0.25 is 2, 0.2 divided by 0.25 is 0.8. Similarly 0.25 divided by 0.25, that is 1, and 0.6 divided by 0.25 is 2.4. so this is our I minus A inverse. This is our I minus A inverse. Now comes another part of the question. We are told that the final demand changes from 18 to 44. So in place of 4 and 32, we have 80 and 44. So I will write here, we can write that x will be equal to, x is equal to, that is equal to I minus A inverse I minus A inverse times the new demand, that is D1. So now our new demand is 18 and 44. So in place of I minus A inverse, I will write 0.812.4, and our new demand is here 18 and 44. So I will multiply it by 18 and 44. Now we have to find the product of these very elements. Now we know we multiply first row by the first column, so this will become 2 into 18 plus 1 into 44. Similarly, first row, the second row, then first column, so this is 0.8 into 18 plus 2.4 into 44. Now when solving this further, this will come out to be 80 and 120. I have already done the calculation. This means that if final demand, that is, if final demand is 18 and 44, gross output will be 80. Sorry, I have written on this here 80 and 120. That is, if the demand final demand changes from 4 to 80 and 32 to 120, we have to produce 44 units instead of 40, and 80 units instead of this will remain, sorry, this is here 120, so it is here actually 80, and we have to, in place of 80, we have to produce 120 output. So this is how it is done. So here it is to be remembered, first of all we have to see whether the system is viable. Viability is found by seeing whether the Leontief matrix, the determinant of Leontief matrix, is positive or not. If it is positive, then we can proceed. If it is negative, because output can't be negative, so the system is not viable. So in the next video we will see the actual mathematical